Welcome everyone, and thank you for attending today's Healthcare IT News webinar, Benefits of an API Strategy for Value-Based Healthcare, sponsored by Red Hat. I'm Mike Milliard, editor of Healthcare IT News, and I'll be your moderator today. Massive changes in healthcare delivery, regulation, and payment make access to data, connectivity, and integration more important than ever. Collaboration can be among patients and doctors, among hospital staff, and among hospitals and other healthcare organizations, including insurance companies. Traditional messaging is being replaced by APIs, largely through the FHIR standard and other API efforts, but what does that move to an APIs entail? During this presentation, you'll learn why APIs are so much better than the current messaging technologies used to share healthcare information, how APIs support digital services in healthcare, and how customers are using this technology right now. Our speakers for today's event are Jess Perkins, Director of Healthcare Business Development, and Samar Choudhary, Principal Architect at Red Hat. With that, I'll hand it over to Jess to begin the presentation.
Great, thank you for that introduction. I appreciate everyone's time and attention today. We were going to discuss the benefits of an API strategy for value-based healthcare. So where do APIs benefit in a value-based environment, and why are they essential? So we thought we would talk about why is Red Hat qualified to discuss this? Where do we play in the healthcare market, and what do we bring to the table, of course? Where have we been with APIs, and where are we headed, and why? We plan to give a technical overview of Red Hat integration and API management as well. And then, kind of as a wrap-up, what questions should your IT team be able to answer? And then question and answer session. So moving ahead, what are the qualifications for Red Hat in the healthcare market? If you're not familiar with Red Hat, just as a brief overview, Red Hat enables open source technology. So if you're familiar with open source, the community model, open source really got started because no one company could deliver in all areas of technology that is needed in the market. So from the big players to the small, no one really delivers, and that's where the open source communities spring from, where companies typically have needs and they go to a community to fill those needs because they can't get what they need. Open source, most people are familiar with Linux, but there's many areas of other innovation around big data, software-defined storage, certainly the cloud. All aspects of the cloud are supported by open source communities, OpenStack, mobility, business process management, etc. Open source really has delivered way beyond what companies typically deliver. Red Hat, we enable open source for a business environment. So we add things to open source software that make it usable by a business. We've done very well in this. We're on track now to be one of the top 7 software companies to reach $5 billion in the next several years. Little profile of Red Hat. We actually founded in 1993, and you can see the timeline across the top. We've been doing Linux for many, many years, but we also have many other technologies, again, that we bring to the market, and we'll be speaking to some of those today. Red Hat is around, I think last quarter we were about $2.8 billion in annual revenues. We're well across the Fortune 500. The company is now over 10,000 employees. We're global and really have a strong presence in the market that's done nothing but grow. In terms of where we are in the healthcare environment, and again, why we're qualified to speak here, we power really all of the top areas of healthcare: pharma, health systems, payer, provider, public health, government-based healthcare. Many of the ISVs in the market base their solutions on Red Hat. We're in 9 out of the top 10 pharmaceutical organizations. We're in about 70% of the health systems across the company. We're in all of the top end of the payer market, and many of the ISVs, the software vendors in the market, base their technologies on Red Hat offerings. So what's changing in healthcare? What's precipitating this? Really, if we back up to where did healthcare integration start? In early days of automation in the 80s, point-to-point interfaces started up, generally speaking, in the laboratories. So laboratory systems that needed integration to their devices, laboratory devices, they started at point-to-point integration, which quickly became out of control. Healthcare was the largest point-to-point integration market in the world and across any vertical, and they didn't even intend to do that. And that was, again, these were in the early days of healthcare automation. That led rise to the interface or integration engines, which are still vastly in use today. If you're from a healthcare organization on the provider side, you're likely using one of these integration engines that's in the marketplace. The integration is typically based on HL7 version 2.x. There's 2.1 through 6 nowadays. Version 3 came out probably about 10, 15 years ago. It never really took off. There are some global implementations of it, but it's pretty complicated. Version 2 is a push message, and it's document-based. So essentially, when you get a version 2 message, you're getting the whole message. You have to parse it out. You have to understand what's in the message because there's not standardization within the payloads themselves. And the message has to be pushed from one organization to another. Version 3 attempted to tackle semantic interoperability, and it has a reference information model, or the RIM, attached to it. It's also message document-based. And CCDA was an attempt to try and filter through, because when you get these documents, they're massive. They can be absolutely massive. And the CCDA was an attempt to boil that down to clinically relevant information, but it's still a full document. And this is kind of where we are today, is around these older versions of HL7 messaging standards. Healthcare APIs, again, recently have come out. Probably the most visible use case for this was in 2010, the VA came out with what they call Blue Button. And if you're not familiar with this, it was a button on their website that patients could go in and view, download, and transmit, or BDT, their personal health record information. So again, where you have a patient that has a tremendous amount of healthcare information, you know, they'd go to their provider and they would get it in paper copies and try to carry it to another provider. This could be suitcases full of paper, literally. So the VA created this Blue Button using APIs out of their system, and it really was very well received in the VA healthcare community. In 2014, HL7 released their first draft of the FHIR API standards. And in 2017, they've done a final release of Release 3, which is now published as of this year. Meaningful use, again, if you're from a provider healthcare organization, you're certainly familiar with meaningful use, the money that's available from the government to advance health IT automation. In Stage 3, Objective 3 of 6, as of this past August, it was revised, but it's that the patient is able to view, download, and transmit personal health record information, and I've got the quote here from that publication from CMS. Many of the practice management systems have offered APIs for some time. I've seen the number 80% of those systems. They tend to be smaller, less complicated, of course, than the hospital and the EHR vendors. But there as well, the health system vendors are now beginning to offer FHIR-based APIs across their systems. So we're definitely moving in that direction. And why does it make a difference? If you look at the fee-for-service systems that are out in the market, they're transactionally based. So the fee-for-service model of payment is a transaction-based payment. The more knee surgeries I do, the more hip replacements I do, I get paid. And we're all familiar with the points on the care continuum that are in these red boxes: physician office systems, emergency departments, clinics, hospitals. These have application function within their own entity. And the sharing comes when you try to go across these silos and have patients transfer, et cetera. So early efforts, of course, the EMR, EHR used a unified data set and then HL7 messaging to try and pull and push information. And wellness really wasn't addressed. The providers generate claims that go to the payer. The claims are processed by a claims adjudication system for payment. A lot of analytics and BI goes on in the payer market. They're fairly mature with this. And there's typically, the payers will try and do some level of care management, and it's based on claims historically. So they'll take the claims data to identify patients with various conditions, put them in care programs, and try and manage their care across these silos to make sure that they get the highest quality and the lowest cost, of course, the holy grail of healthcare. But that's how it's done historically in the market. When we move to a value-based model, the payers will shift the risk to the provider side. So they'll pay, whether they pay on a per member per month calculation or some sort of performance-based calculation, the idea is that they share the risk with the provider, the risk of providing care at a profitable level, profitable payment model. So the care management, the issue of how do I manage these people, whether it's a person, whether it's a member, whether it's a patient, how do I manage people across the care continuum from end to end to keep them as healthy as possible with the best outcomes where they do have interactions at the lowest cost? That's now in the hands of the providers. Now, if you step back, as we saw in the previous slide, each one of these red boxes is an individual transaction-based software application. So you need something, and this is represented in the light green box, where you can manage that population. You can manage what are the aggregate statistics and data and identifiers for people who do need help where interactions will be of value. How do you get the member or the patient engaged in their health care? And how do you manage those dollars of risk? So there's a new level of application, and we've all seen these emerging in the market, that really goes across these silos in healthcare, and wellness is definitely captured because obviously now you're as a provider, you're incented to keep the patient or the person well. You're incented to keep them out of these silos as much as possible. So how do you do this? How do we add a broad longitudinal application on top of our transactional systems? You can't do it through claims. Obviously, claims are financial data. They're oftentimes delayed 60 to 90 days, so you're not going to have any kind of effective operation if you try to base your management in terms of claims. That's, of course, that's not going to work. So really, you need APIs that can be plugged into the application level, the data level of all of these red boxes where you can pull and push information, not just push. You need query capabilities. You need the ability to drive that through APIs. There's really not a better way to do this. So this is the reason for the excitement and the adoption, really, of APIs that's coming, that we're seeing in the market today. API opportunities, if you think about, rather than doing a push message full document standard, now if we have APIs, we've talked about the possibilities in the facilitation of care and risk management around the organization, but there's about a million other spots. You can integrate data into workflows. So if I'm doing a patient admission, for example, and that's a 28-screen pathway, and in screen number 11, there's a question about do you have a history of tuberculosis or infectious medicine, or infectious diseases? How great would it be to be able to certainly ask the patient that you're admitting, but also branch out to maybe an infection control database or any sort of registry. You can augment the workflow from any external source, any internal source. You're able now to go into the pathways of workflow without having to wait till the end until you can create an HL7 message. You're able to integrate this into the workflow and really provide a much higher level of support for those actions. Reducing the dependence on a single EMR platform. Healthcare, as we know, is undergoing incredible consolidation, and nobody really wants to rip and replace. APIs give you far more advantage and capability to integrate the operations of multiple entities without having to rip and replace the systems. I'll continue on here a little bit, but you guys can certainly grab the ideas. Enhancing resource management and improving patient throughput, getting people off the phone. Where people are on a phone, the first thing you should think is, could we do this better? Could we do this through an API and let the systems make decisions and gather information where the systems can do it, and save your people in phone calls for where they can't, where human interaction is really needed. A seamless approach to care management we covered, facilitating member-patient engagement. Again, back to that view, download, and transmit. That's just grabbing the information, seeing it, and transmitting it. APIs allow you to get deeper into what's really, sifting out what's really relevant versus what might not be so relevant. Clinical disruption through broadened application function. And the last one, and again, these are just a handful of examples, there's many more, but the health IoT, connecting medical devices, whether they're bedside, home-based, standardization in this area really can facilitate better use and better decisioning with the devices and the device information. Some of the challenges in leveraging these APIs, now that we've been given an advantage, how do we make that work? You're going to have a mechanism to govern the massive amounts of APIs that are now available. So it creates a governance issue that you really have to address from the get-go. You can't do that in your second year or something along those lines. It's too large of a project. The security of APIs, of course, we always have to think about security. How do we manage those rights and the access capabilities? You need a platform that's going to be flexible and scalable and reusable. Of course, we want all of that. That's the advantage of APIs. You just have to, now you have the responsibility to manage it. And you need an integration platform for multifaceted integration. So with these challenges stated, I think now is a good time to turn it to Samar Choudhary for a little deeper technical presentation of the topic. Samar?
All right. Thank you, Jess. Thank you for showing us the what and the why of the problem space that we are talking about here. What I'm going to talk about is the how. What do we do from a technical perspective, and what solutions do we bring to bear from a Red Hat perspective? So as you can see, we have essentially 3 products listed here, and we'll talk about these products in details over the next few slides. But let's introduce those products first. So what we have is the API management framework, which is called the Red Hat 3-Scale API Management. This is basically responsible for managing a governed set of APIs. And I say governed because these are all managed, they're secure, their permissions, their usage metrics, et cetera, et cetera. Then there is the distributed integration framework, which we call Red Hat JBoss Fuse. This is a lightweight pattern-based integration. It is called distributed integration because we basically deploy it on our container as a service or platform as a service called Red Hat OpenShift. And what makes it distributed is the fact that when we go and develop an integration application here within JBoss Fuse, we can deploy it on Red Hat OpenShift, and then it scales up, scales down, and works as a set of microservices within the container framework. This is actually a great concept because typically a lot of frameworks, integration frameworks, tend to be centralized. And what we are talking about here is a distributed integration framework. The other thing I wanted to point out was that while I'm showing 3 products here, the 3-scale API management is perfectly capable of going and integrating with any other integration framework. So if you had, for example, your integration framework here, and let's say for the sake of argument that was running on your own platform, whether it be on-premise or in the cloud, the APIs really doesn't care, right? The APIs basically can go and connect to any one of those backends, which run on whatever platform that you desire. So that's the other point. So in reality, if you want an API-led framework, you would start off here. If you want to basically go into a distributed integration framework, a more modern architecture that's based on microservices, not a single point of failure, more distributed, you would go to something like this. This slide basically shows the architecture. So you can see that the 3-scale API management is a vertical set of capabilities. It's vertical because the idea here is that it spans all your applications. At the end of the day, you want all your applications exposing APIs, and henceforth, it is considered to be a vertical capability. It basically connects to the integration framework. In this picture here, this is just a reference architecture. It connects to the Fuse integration framework, which then basically runs on OpenShift, Red Hat OpenShift. One of the important things here that you can see is that while we do support container native applications, we also allow you to basically connect the Fuse to non-containerized software as well. So there are several deployment models you can go with. You can go with 3-scale as a standalone that connects with your integration framework that runs on some platform. You can go with 3-scale that connects to a Fuse integration platform that basically does not run on OpenShift, or you could go with 3-scale with Fuse that is also using non-containerized software. So there are many, many deployment options that are possible. Now, what does it look like today versus what are we trying to go for, right? So the traditional integration, as we already know, is based largely on enterprise service bus or integration framework that is centralized. Now, what that means is that if let's say there are 10 application teams, and all the integration platform runs on a centralized integration platform. If one team wants to make a change, that could potentially affect every other team. And that's what we mean by centralized integration. That is obviously very hard to manage, very complex, especially over time as your number of integrations grow. It becomes virtually impossible to manage, and it is extremely slow. Now, one of the things that people talk about are microservices, and they say, everything can be solved by using microservices. What are microservices? Microservices are self-contained entities that basically perform a particular task. So for example, if, for the sake of argument, for an example, if I had a pricing microservice and a list of inventory microservice, instead of building that as a monolithic app, we would build them as separate applications altogether with the idea that we would combine them later. An API is a great way of basically taking the capabilities of these two applications and then aggregating the output, so to speak. But that could also lead to hundreds of application microservices. So how do we solve all these problems? So what we are basically advocating for is, let's reshape the integration model. Integration is much needed, it's necessary, it's here to stay, right? But what we need to understand is, how do we go and implement this in reality? So instead of having a single center of competency for our integration needs and one team that basically goes and deploys and manages the integrations, what we are saying is that let's send out all our integrations to multiple teams. These are multiple independent teams that can work independent of each other. And the way we do that is by basically, writing an integration, then deploying it as potentially on something like a container framework like OpenShift. And then these containers basically get instantiated, they run independently, they are managed independently, they're brought up and down independently, and so on and so forth. So we are basically going from a central model to a distributed model where the load is shared by everybody. And this basically makes it obviously very agile and very, very rapid changes. So what is Red Hat JBoss Fuse? It's basically a lightweight integration framework that is based on Apache Camel. I'm sure all of you guys have heard of Apache Camel. It is the most popular integration framework out there, which basically has a bunch of reusable pattern toolkits. It has great, and we'll talk about what that means on the next slide. It has great capabilities around transformations, routing, messaging. One of the important things that I just wanted to quickly touch on is that it includes the JBoss AMQ for messaging. So for example, if you have a situation where a request comes in for integration app, and then you want to basically queue the message, then you would basically use JBoss AMQ. This would be very useful in a situation where there's high throughput and you want guaranteed delivery. So pattern-based integration is based on integrations using enterprise best practices. We've been working on this for years and years, so have a lot of experience here. You can see that we have 150 plus components, and being open source, the benefit here is that people keep contributing more and more components. So we have every component that you can imagine, whether it be batch, real-time, whether it's based on SOAP web services, whether it's based on REST web services, API, what have you. We have connectors that go on to social media, Twitter, Facebook. We have connectors to databases, Salesforce, anything imaginable, to be honest. Built-in data transformation, so obviously we understand that everybody has their data in different formats. So for example, you could go from XML to JSON or JSON to XML. We do support HL7. We support YAML, CSV. You can write custom code as well. And we have some tooling. We'll touch briefly on the tooling today. We have tooling that is based on Eclipse. We have tooling that is online, which is web-based as well. That's the direction we are heading in. And last but not the least, as we mentioned earlier, we can take our integration frameworks and then we can basically put APIs in front of that. We have three flavors of JBoss Fuse. There's the Fuse standalone, there's the Fuse integration services, and what is coming down the pike, probably first half of next year, is the integration platform as a service. The Fuse standalone is our classic integration, where we basically ship the JBoss Fuse product. You can run it on your platform of choice. It has a nice IDE, which is Eclipse-based, and you can go from there. Then we moved on to the next phase, which is called the Fuse integration services. This is called the scale-out Fuse, because what we do there is we take the integrations, we put it on Red Hat OpenShift, and then we are not responsible for the scale up, scale down, the management, the isolation between the different integration applications, and so on and so forth. All that is taken care of you out of the box on our platform. And that is our next level of integration. The third phase that we're moving on to is the integration platform as a service. This is basically an extension to our OpenShift concept, where we basically are creating an online web-based tool that will run on OpenShift online. So we have something called OpenShift Online, where you basically go and request, your applications to run. It's just like Amazon or AWS. You basically go to OpenShift Online and you request, your applications to run on that. And as part of that, we are developing an integration platform as a service UI that basically, you log in, you do a drag and drop of the different kinds of patterns and the different kind of connectors that we have, and then you basically build your business workflows. So moving right along, of course, we talked about the integration, but we also have this product, as we said, the 3-scale API management platform, which basically talks about exposing your internal APIs to become external. And once you do that, the APIs are visible to whoever you want it to be visible to. You have access controls, so you can manage, who gets to see the APIs. And once they see the APIs, what they can do is they can register for the APIs. And once they register for the APIs, they get some credentials. So they can take those security credentials they can invoke the APIs, and then they have access to your business capabilities. So it provides a global visibility. It obviously allows the team to deliver their own APIs. What a lot of the teams are doing today is that they basically go and develop their business applications, or they already have business applications. Then they basically go and expose the APIs, and then they decide that they want to change those APIs. So they basically standardize on the API signatures, and then they expose those APIs. They do change the backends from time to time, but they try to make sure that the APIs remain the same so that the third parties who are using the APIs are not affected. This allows both the parties here, the application developers and the partners, to basically develop their own applications at a different rate and pace without affecting each other. Once in a while, of course, the API, the internal implementation changes, and you may have to tweak the APIs, in which case you will have to basically start talking about versioning of APIs, and the 3-scale API management framework also supports that. So this is essentially talking about an API-first approach. And like I said earlier, it's a great way to expose your capabilities. It's a great way to isolate the partners and the application developers from each other as well. So here are some of the capabilities. Let's start from the right to the left here. It is highly flexible. You can do multi-departments. So for example, if you wanted to isolate multiple tenants, or let's say you have a customer that have multiple organizations, you can go and implement those kind of things within 3-scale. It's highly scalable. It has powerful APIs. So the other thing is that it also has APIs that it exposes for its own capabilities. So you can go and whatever you can do from the user interface, you can also do through APIs. And it also has the notion of webhooks. So for example, if you're onboarding, if somebody is getting onboarded, a customer is getting onboarded, then it basically generates events that you can basically go and write some custom code against, and things of the nature. So there is a lot of flexibility in the platform. And obviously, when you basically go and expose APIs, people are going to use it. So once you expose the APIs, there'll be some people who will come in. They'll say, I want to start using these APIs. They'll register. Once they start using it, that we want to make sure that they don't overuse it or abuse the APIs. So what we do there is we basically implement a bunch of policies. So for example, there's the rate limiting policy, which basically suggests that, let's say, customer A is only entitled to 500 requests per hour, and customer B is entitled to maybe 1,000 requests an hour. And if you go above that, then we're going to stop you at that point. So there are notions of policy enforcement, which you can do. You can also build your own policies. The app and user management just talks about the fact that there are different external applications that register for the APIs and start using it. And those are the applications that we want to monitor. And that leads us to the visibility aspect, which is, okay, so we now have APIs that are being used by people. We want to make sure, we want to understand which APIs are being used, how they are being used, who's using them, what's the frequency of usage, et cetera, et cetera. And this is where the app tracking, user tracking, and all that stuff comes in. And of course, if a user or an application starts exceeding their policy or their quota, then we basically have the notion of alerts that will alert someone regarding the overusage, so we can actually take some action. And the action could just be sending email to the user and saying, hey, you need to increase your quota or something like that. There's, of course, the developer support. This is an entire life cycle of API management. At the end of the day, the developer is the one who starts off by, writing the API. Somebody publishes to the developer portal within 3-scale. And then the external application developer basically registers for those APIs. So we have developer support, we have application support, and so on and so forth. This is a deployment architecture of what the 3-scale API management looks like. You can see that we have the API manager, which is basically nothing but think of this as the user interface. And, so there are two parts to this, the admin console, of course, where you get to see the analytics, you get to do the access control. The developer portal, where you get to build your APIs. So we basically support Swagger specification for building APIs. and you can try out APIs as well over there. And of course, the APIs are run through some runtime, and this is the gateway here. This is where all the APIs are sitting, or deployed, I should say. So any request that comes in actually comes in through the load balancer. So for example, the developer apps, the mobile apps, they basically come through the load balancer. They hit the API gateway. The API gateway then goes and talks to the back end. And of course, when they're hitting the API gateway, the metrics of who's using it, how they're using it, et cetera, needs to go to the API manager, which is sitting here. Now, the important thing here is that even though this is a very generic deployment architecture, you can deploy your gateways on-premise, and you can deploy the API manager in the cloud. Or you could alternatively also put the API manager on-premise. So the whole thing could be on-premise. We give you a wide variety of deployment choices, and it's really up to you what you pick for your organization. And here is an example of an integration-driven scenario. This is being used at the Amsterdam airport. And what they have done there is they've basically taken our 3-scale API management and our JBoss Fuse. They're now basically exposing some of the capabilities to their partners. What they're not doing is they're not exposing the customer data, of course. The kinds of information that they expose is around, flight status, flight times, and things of that nature that are a little bit more generic and, don't have quote unquote, security issues. Obviously, you don't want to be exposing the, your customer data and the date of birth and so on and so forth. So you can certainly do a search on this use case. It's widely advertised, readily available. Just do a search on this, and you'll find this instance. So at the end of the day, what are we shooting for? What we discussed here was an API-led approach. We talked about the fact that having APIs is a great way to start because it isolates you from your business applications. It allows you to aggregate things like what Jess was talking about in a great way. You can use APIs. You can integrate with our backend systems through JBoss Fuse, or alternatively, you can use your own. And that can run on Red Hat OpenShift for scale up, scale down, a distributed integration model, et cetera, or you could decide to use your own. So what we are shooting for at the end of the day is changing, improving, and adapting how customers engage and interact with an enterprise and how your business processes are designed so that the workforce collaborates in response, and how business partners in kind must react to new opportunity and ways of doing business. So we have an end-to-end story here, and with that, I will pass it to Jess.
Great, thank you, Samar. I appreciate the overview. So in summary, where do we go with this? What is a consolidation of the opportunities? And back to the questions that we were asking for healthcare organizations, do you have a plan to accomplish this kind of integration? Really, the business models are driving it, the healthcare value-based care business models. So what's your organization's plan to accomplish this integration? Do you have you probably have some of the pieces, you could reuse some of the pieces or not, but you've got to work through that and figure those points out of how to implement it, but also how to leverage it and how to make use of it for your organization in a positive way. Do you have the technology that's needed? How can you expose the data, and can you manage the data securely? These are real questions in terms of the how of deployment. And can it generate revenue for your organization? Is there an opportunity? And there is. It's buried in there. Again, that's why we're moving to these value-based care models. People who do it well and do it right will wind up on top of this. So where are the points of revenue generation within the organization? And do you have all the technologies to position yourself for the future? We've talked about integration, but once you get APIs and once you get a true, seamless, real-time, instant integration, layering in a rules engine. In other industries, that's the natural follow-on. And some of the integration platforms today, the integration engines, they have a pretty rudimentary rules engine in them, but they've got the ability to route the information. Rules engines can be much broader than that. When you combine it with business process management functions, in other words, workflow automation, complex event processing is CEP. It's a rules engine on steroids, essentially. Messaging, we talked about the API management. How do you want to administer this in terms of a cloud or hybrid cloud environment? And where does containerization benefit the organization in terms of trying to manage these sorts of deployments? When you look at the larger stack, it enables API integration, but it also can drive significant opportunity, business opportunity for your organization. So really, these are questions that need to be considered when looking at leveraging API management. And you know, in this whole environment right now, we've got the opportunity, and you may or may not agree that these are times of peace, but certainly in terms of this topic, you have the opportunity to prepare for the future. So in times of peace, prepare for war, was said by a very famous individual about 2,000 years ago. Anyway, we thank you for this, and I'll turn it back over to the leads. I think we're going to do a question and answer period. Thank you.
All right. We have some questions lined up already, and we do encourage you to enter some of your own in the Q&A panel here. So let's get to the ones we have. Thank you for a terrific presentation. First up, we have someone wondering whether you could, kind of compare and contrast the integration of data with APIs as opposed to machine learning and artificial intelligence.
All right. So this is Samar. I'll take that question. So integration of data with APIs versus machine learning. So machine learning is all about basic algorithms, right? You're basically trying to run some calculation, so to speak, algorithms, let's say, that allows you to basically go and learn certain behavior. So there are several examples, right? Classification, for example. Let's say for the sake of argument that you have trained a particular set of outcomes, for example, true or false, right? Is this, and then you get the next item in there, and you basically then classify it based on your experience or expertise in building the algorithm and the intelligence. API does not deal with that kind of logic. So API is completely agnostic to business logic. API is basically, think of API as a smart proxy, a veneer, a smart veneer, if you will, that basically sits on top of any business capability. And so in particular, in this case, one of the use cases for artificial intelligence and API management would be something like you've built a set of algorithms that does something for you, and then you want to expose that capability to your end user. Maybe the end user is sitting on a web UI. Now, what you would do there is you would basically write a set of APIs that would then connect to these AI algorithms under the covers. And so your UI is connected to the API is connected to your artificial intelligence algorithms. That's kind of how you would read. So I see them as being complementary in that sense. Now, one of the good things about API management, of course, is the governance aspect of it. So one could easily argue that, hey, I can just put an API in front of my AI stuff and I'm good. Why do you need governance? The reason why you need governance is for a couple of reasons. First of all, it allows you to track who's coming, who's going, the usage, etc. It allows you to define SLAs and policies. And last but not the least, it also allows you to expose your business capabilities via documentation and develop a portal to the rest of the world. So, back in the good old days, we all had APIs, but they were all internal. And what we're talking about is now taking your AI in this new use case and externalizing it, putting it on like a website with documentation, with the ability for people to log in, to register for those APIs and start using them. So you expand your ecosystem and things of that nature.
All right, another question here. When, how, and why will API strategy be superior to an XDS data management and asset query process? Won't APIs need an XDS model to query across platforms?
All right. So frankly, I mean, I'm just going to have to glean some information from the XDS data management and asset query process. I'm assuming it's some kind of, master data, warehouse, repository kind of stuff. I may be wrong here, but I'm guessing at the end of the day, it's an application that has some data in it and does some interesting queries, reads, write, updates, etc. If that is the case, then the response is very similar to the previous one. So if you have a use case where you want to have the ability to expose, let me take a step back. You may actually have two use cases there, right? One is you want to expose these capabilities directly through APIs, and what you would do there is you would basically, again, develop your API. It's just basically a REST API, if you will. That REST API will then directly connect to your system. In this case, and I don't have that in front of me now. The data query system, and you could go that way, or if the data query system actually happens standard, if it supports standard SQL queries or something like that, then you could actually even go directly from APIs to something like Fuse, which is an integration layer that has connectors to everything imaginable, including databases, and you would use that route. So again, to me, the answer is not very different. It's a complementary set. What APIs give you is a very simple, easy, and quick way of exposing your business capabilities. So one of the use cases where it's really good for what it's really good for is, what we call as two-speed IT. And two-speed IT basically means that everybody recognizes that we have a whole bunch of systems in place. And because we have a whole bunch of systems in place, it's hard to change because you're going to affect all your customers. So what do? So what you do there is you basically expose these capabilities through APIs. So every call comes to the API and then directly connects to your backend process, whatever that may be. Maybe AI, it may be your XDS, what have you. And by doing that, what you're doing is now you're basically exposing these capabilities to the outside world, to other programs, and so on and so forth. And you can build many, many interesting use cases by combining the two. So just to use the two previous questions, one interesting scenario, and I'm just making this up, of course, would be you would basically, get data out of XDS or some system like that. My apologies if I'm not clear on what the system does. And then you could basically pump that data into an artificial intelligence or machine learning, like an Apache Spark or something like that, which would basically run the machine learning algorithms on top of that to glean more information out of it, right? So you could potentially use it that way. And in order to do that, if you expose both these processes through APIs, then magically, they don't need to know about each other's internal details, right? They can, they can talk to each other through the simple APIs. And that's the way I think, at least I look at it.
All right, another question here. Oh, I'm sorry. Someone here is saying, I've experienced issues with APIs when volumes of messages become over about 100,000 messages per day. Can APIs overcome this, or does the volume or data load need to be smaller compared to today's heavy HL7 hospital traffic?
Okay. All right. So there are no limitations on, how many calls we can make. So the function of the API gateway, as we call it, right, is the characteristics. There are three things that we need to worry about. One is, of course, the payload size, which, as the question rightfully points out, could be small or large or medium, whatever the case might be. The other one is the number of requests. And the third one is the number of concurrent users. How many users do you expect in a certain time frame? I think those are the three key metrics that we look for. So, for example, if you're talking about large messages, then of course something has to give. So what you do there is you basically then assume that your API gateway is going to take smaller number of requests. Okay. Now all those three parameters can then be taken and mapped to your sizing, right? So we have absolutely no limitation on what we can do when the number of requests or the size, et cetera. But of course, at the end of the day, it's hardware, right? So what we need to do there is we need to basically go and look at, what the requirements are, what these three metrics are, and then we basically need to map it out. And in some cases, we'll say, well, your throughput, your load can be handled by 2 gateways. In some cases, we'll say we need 4, just because you have larger payload and we need to, spread the wealth around, right? The other important thing I wanted to point out here was that this whole notion of scaling, which we provide through our container as a service or platform as a service, Red Hat OpenShift, is very nice, because what it does is it automatically scales the instances for you. So for example, if you had 2 and maybe suddenly there was a heavy load, then suddenly it will scale up to 3 instances. And if the load goes down, it will scale back to 2 or 1, or whatever the case might be. So we got lots of ways to tackle these kind of issues. So yeah, I do agree with the question that when you have a larger load, you just have to be, you just have to be careful about how you manage your planning, and then how you, build an environment that is, that believes in auto scaling. Those are some of the things that I think would definitely address the problem.
All right. Well, I'd like to thank Samar and Jess for a really terrific and informative presentation. So thanks again, and thanks, of course, to the audience for joining us today. And as we wrap up, I would like to ask you to please be sure to complete the evaluation that will be popping up on your screen and share your thoughts with us. And just a reminder that today's session will be available on demand until November 14th through the HIMSS Learning Center. Thanks again, and have a great day.